Introducing functions, lesson 12 notes continued. Before looking at example number 1, we're going to look at some more examples of functions to determine if they are a function or a relation, or just a relation. All right, so let's look at number 1. Okay, remember the first thing you look for are repeating x values. Well, I've got 1, 2, 3, and 4. They do not repeat, so it's automatically a function. Don't repeat, so it's automatically a function. For number 2, I've got 1, 1, 1, and 1. So the input of 1 has outputs of 1, 2, 3, and 4. Since 1 has more than one output, this is not a function. Again, you should just be following along. You don't need to write this down, but follow along. Number 3, I have inputs of 1, 2, 3, and 4. None of the inputs repeat, so it's automatically a function. Number 4, I've got 1, 0, 2, and 1. So I do have 1 that repeats. The input 1 repeats, and it has outputs of 0 and 2. 0 and 2. Since the input 1 has 2 outputs, it's not a function. If it has more than one output, it is not a function. The last problem. We've got 1, 2, 3, and 1 again. So 1 repeats. I've got 1 and 1. So let's look at its output. I've got output of 2 and an output of 2. Therefore, the input 1 has just an output of 2. Even though it's listed twice, it's still the same output. So if you have an input listed more than once and it has the same output, it is still a function. Okay? If you have any questions on that, let me know. Now, sometimes though, they give us relations that come in chart form. Right? You still have ordered pairs. The 0, 1 is an ordered pair. 1, 2 is an ordered pair, and so forth. So we want to determine if these charts represent a function or not. So you want to see, do you have repeating x values or not? Well, for number 1, I have 0, 1, and I have 0, 4. So they are repeating x values. So the input of 0 has outputs of 1 and 4. Therefore, this is not a function. I'm just going to abbreviate since I don't have much space. Number 2, do I have repeating x values? I sure do. I have 0, 1, and 0, 1. In this case, the input of 0 has just an output of 1. Therefore, this is a function. Number 3, I've got input of 3, input of 3. That repeats. So the input 3 repeats, but the outputs are the same. Since the output is the same, it is a function. And for number 4, what input repeats? That would be the 4. Input 4 has outputs of 9 and 17. Since input 4 has more than one output, this is not a function. Okay, so now after those examples, I hope you have a better understanding of how to look at a relation, a group of ordered pairs, or to look at a chart and determine if it's a function or not a function. So let's go back to our notes and let's look at example 1. All right, do these represent functions or not a functions? Go ahead and write down what you think it should be. All right, so let's look at example 1A. Do I have any repeating x values? I sure do. The 4 repeats. So I have 4, 10, and I have 4, 5. So that means input 4 has 2 outputs, 10 and 5. So the input 4 has outputs of 10 and 5. Since it has more than one output, this is not a function. Please write all that down. All right, for B, do I have any repeating x values? Just so you know, 10 and negative 10 are not the same thing. 10 and negative 10 are not repeating. I do not have any repeating x values. And when you do not have repeating x values, it's automatically a function. All right, so make sure you have all that written down for example 1. So again, if you have input values that repeat, then you have to look at the outputs. If for those repeating inputs, if the outputs are different, it's not a function. If they would be the same, it would stay a function. If you have any questions on example 1, please let me know.